So, hello everyone, and welcome to this Ask AuxEn Anything session that we have every weekend. And as you all know, it is an online platform for civil structural engineers to interact with us and ask their doubts or queries related to any project that they are doing, or RCC steel design concept, or any site issues or construction related problems that they are facing. So, this is the 35th such session that we are conducting, and let us begin with our queries. So, as we always do, I'll begin by taking the queries from the Google form, and then we will take up queries from the uh, live comments, if any. So, let me just begin. Right. So, first query is from engineer Ajinkya Dinapurkar. He is from Noida and he is a working professional. So, let us see what he has asked. Yeah. So this is the query asked by engineer Ajinkya. What he is saying: in the design of beams for ductility, we consider this larger of analysis shear and the capacity shear due to the capacity shear. But in case of coupling beams, if we are providing steel plates for shear instead of diagonal reinforcement, do we need to consider this magnified shear? Correct. So what he is saying is, uh, what we usually do, that if L by D is more than 4, okay, that means the span divided by the depth of coupling beam. If this is more than 4, it is usually going to be flexure controlled failure. So this is, I am giving you a practical viewpoint that you can follow in design, because code is not very clear on this issue. So therefore, I am giving you a practical approach. So if L by D is more than 4 for your coupling beam, what is a coupling beam? So if let's say in elevation, if these are your shear walls, two shear walls, okay, and you have coupled them by attaching beams like this. Now this may be the case because you wanted some opening over here at floor levels, that's why this sort of geometry was formed. Or if even if there's no opening required at floor level, just to increase the efficiency of walls in these two walls in your building, you are attaching them with this element. Okay, so now his query is that for considering the shear force in this coupling beam, should I consider the analysis shear or the magnified shear due to, you must have seen this type of formula, okay, this type of formula, and to that we add the gravity shear due to dead plus live. So he's saying, should we consider this or the analysis shear? So that is what I'm trying to answer. That as per the practical approach, if your L by D span upon depth ratio is more than 4, it is usually flexure controlled. And for this, you can just design it as per the analysis shear. You get my point? Design it as per the analysis shear. This is not written anywhere in the code, just from the practical. I'm giving you a practical approach. So design it as per analysis shear. If your L by D is less than 2, or I think 2.5, sort of deep beam effect, then you consider it to be shear controlled failures. And for this, you then calculate the magnified shear also due to sway effects. You consider magnified shear due to sway effects, and then you also consider VC equal to 0 because that is what your IS 13920 asks you to do. And then you find out the shear reinforcement as per the codal provision. And for the in between situation, if this is between 2.5 or 2 to 4 L by D of your coupling beam, then you take a call as a designer. Then you take a call whether you want to consider the magnified shear or not. Okay. Generally you will see that for most of the cases your L by D will be between this 2.5 to 4 if your walls are close to each other. So then you have to take a call whether to consider the magnified shear or not. Understood? Okay. So then his next part was, we generally model these coupling beams as shell elements. Therefore, ETABS does not calculate the magnified shear automatically. Correct? Is it, if it is necessary in that case, we need to calculate it manually for each coupling beam? Yeah. No, even if you instead of, because coupling beams modeling them as shell elements becomes slightly tedious, because if you want to change the depth of your coupling beam, then what happens if you want to change the depth of coupling beam, and if you have modeled them as shell elements, things will become slightly tedious modeling wise, because then these mesh, you have already meshed your wall and coupling beam, and so changing the depth will be problem if you have modeled them as shell elements. So even if you model it as line elements, and we have done this sort of comparison in our course on tall buildings where we have dealt with coupling beam issue in detail. So even if you model them as line elements, the results don't change much, they don't vary much. So my suggestion to you would be, for faster work you could even model your coupling beam as line elements instead of shell elements. Okay. All right, so this was his query. Then next query is from engineer Alek Katwal. He's from Kathmandu and he's a working professional. So what he is asking, let me just copy and put it over here. So engineer Alek from Kathmandu is asking, if we have to apply wind load on steel building having 3 stories and roof truss. So his case is in elevation, let's say uh, he has 3 stories. So this is G1, 2. Let me add one more story, 3. And then on roof, he has got a truss. Okay. So he has got a truss like this, steel roof truss. Shall we have to apply different wind loadings on roof truss and other part? No, so you can refer to the codal provisions for walls. You can apply the wind load that is applicable on walls. Okay, for roof you can apply the wind load that is applicable for roofs. So you can refer to IS 875 Part 3 for it. So although that they have not covered a mix situation where you have got RCC plus steel, but then you could apply the logic, and then for walls you could take the coefficients from the table which gives you coefficients for walls, and for roof you could take the coefficients that are given for steel roofs. Okay, so this is what you can do. That was his first part of the query. I want to model roof truss separately and apply load in RCC columns that support the roof truss. Okay, so what he wants to do is he wants to model this truss separately. My confusions are, while separately modeling the roof truss, what height shall I adopt for calculating the wind pressure? So obviously this base height will be this. So for example, if it is let's say, this is 12 meters, just giving an example, and let's say this steel, there was a steel column also, let's say another 4 meters. So then your this basic height becomes 12 meters over here. Yeah, this height becomes 16 meters. So you will need to calculate the K2. Basically, the K2 factor will change as per the Indian standards. So this K2 factor has to be as per 16-meter height. And then whatever roof I'm generally not taking the ridge height, I'm taking the eaves height. So K2 you will have to calculate between 12 and 16 meters. Okay. Okay, so he has given the height actually. My total building height is 15 meters, including 3-meter roof truss. Okay, so I have used these dimensions right now. You follow this. So if 12 meters was your roof height, another 4 meters was column height. So for you, 12 meters becomes the base, 16 meters becomes the eaves. Accordingly, you calculate the K2. While applying truss load in RCC columns, what value shall I use and how to extract and apply the wind loads? So first of all, you need to be careful about this stiffness that you are going to give. Okay. What happens is that many times, let's say here I had modeled a steel column, but suppose you had a case something like this, where this truss was, you were taking the RCC column slightly above, and your truss was resting right on the top of RCC column. Now the mistake that happens is that we generally model only truss like this, okay, and then we assign some support. Let's say you assign pin roller whatever, and then you analyze your truss. But what is happening is here you miss out on the, you are going to miss out on the actual RCC column stiffness. So your results will vary if you considered the actual stiffness of the RCC column. This truss I am assuming was resting on a RCC column over here, black colored line. So if you model this truss just as supported, then you are going to miss out on this RCC column stiffness. So my suggestion would be, let's say if you are going to model this truss separately in some other software, then you model a part of your RCC column also, so that you get the appropriate stiffness of the RCC column, because that will change the behavior of your truss. Okay. So to consider the appropriate stiffness of RCC column, you model a part of RCC column also. Best thing would be that in one model only, best thing would be in one model only where you are considering your building, have the truss also modeled over there. So that will ensure that all stiffnesses are appropriately considered. Okay. Is it clear? Okay. So this was his queries. Let us see what else. Yeah. So this was Engineer Alec from Nepal. And let me just go to next query. So next query is from Engineer Abhijit Sathe. He is working professional and he is practicing in Pune. So his query is, uh, while shoring pile designing, which parameter governs for design? In practice, which shoring system adopted? I have no idea because I have never worked on it. So I don't have any working experience about the shoring pile design. Okay. Neither I have any idea about the shoring system. But generally, what I know is that there might be a steel framing that you may have for shoring, for protecting your deep excavations, or sometimes they do piling also with uh, some RCC wall arrangement. This also they do, uh, or some steel framework. But which system to adopt, what are its technical names and all that, I don't know because I've never used. Which parameter is governing for design? I mean, it has to be the soil pressure, right? What do you mean by which parameter? It has to be the lateral soil pressure that will act on your shoring pile system. So I don't have much working knowledge about it. So unable to take this up. If anyone in the live audience has working knowledge of shoring piles, they may add a few things over here. Okay. Next question is from Engineer Chandrakant. He is a working professional and joining us from Srinagar. So he is saying unable to transfer ETABS model with different shape of column to RCDC for detailing. RCDC showing error, file contains different shape of column. No, this is not an error. This is the limitation of the software. So RCDC, as I understand, is only able to consider square, rectangular, or circular shapes. So RCDC can only detail for either rectangular or, of course, square or circular shapes. So if you have made any other column in your sorry, if you have, and I think RCDC also supports L and T columns, if I remember correctly. RCDC also supports L and T columns, although I have forgotten whether it supports or not. So if you have made any other shape of column in ETABS, for example, any shape that you have made from section designer, dumbbell shape, or any other shape that you have come up, then RCDC may not be able to support it. So it's not an error, it's the limitation of the software. So you cannot do much about it. If it is the limitation of software, it is the limitation of software. Okay. Yeah. So can't do much about it. Maybe then you will have to do the detailing manually on your own without taking help from RCDC. All right. Then what else do we have? Okay. So these were the queries that were asked on the Google form. So we have taken up all the queries from the Google form. Now let us take the queries from live chat or live comments. So engineer Rishabh Thakre is saying, when are rock anchorages used in raft and how to do the design? So rock anchorage you can use in case of uplift in raft. Rock anchorage you may use in case of uplift in the raft. And if your raft has, so I'm drawing a elevational view. If your raft, and let's say these are columns, whatever, if your raft has a tendency to uplift in some portions and you don't have the ability, or you are not in a position to increase the size of this raft further, and there is an uplift over here in this portion, to sort of bring it down, to hold it in place, you may use rock anchorages. So these are nothing but you will do bolting inside the rock. And of course, you need to have such sort of a strata where anchoring is possible, not only in rocks, but in other types of hard strata also. You may do anchoring. So anchoring is nothing but you are just providing holding down bolts or reinforcements also for that matter. And then this will uh, resist the uplift through tension in these anchors. Okay. So the important design criteria that you need to take into account is, number one, the anchoring length. So anchoring length has to be sufficient so as to generate the required tensile load that you have assumed or that you have calculated. So your bond length or your anchorage length has to be sufficient enough for that. Second thing, how to calculate the approximate tension force that your anchors have to take. So in plan view, if this is my raft, let's say, in plan view, this is my raft, and let's say this is my column, and I'm just giving you a very rough way of calculation. And let's say this part was undergoing uplift, and you want to somehow control it, and now you have decided the anchors. So first, if this is the grid spacing that you have decided for anchors, approximately as per the uplift, let's say you are getting some 30 kilonewton per meter square uplift. Okay. So as per the approximate tributary area, you can calculate how much. So this uplift pressure into tributary area will give you how much each anchor has to resist, how much tensile force each anchor has to resist. And then as per that, you could see what size of or what dia of anchor is required, and accordingly calculate the development length or bond length in the rock. And if not, then you can increase the grid spacing, you can reduce the grid spacing, or you can increase the anchor dia, etc. So this type of calculation you can do, and it should also be coupled with actual testing. So pull-out testing should be done. Uh, Pull-out testing should be done on site to just check what is the tensile force each anchor can resist. Okay, so this is a rough calculation you could think of doing. Mr. Rishabh is further asking, can analysis for that be done in SAFE? So for in SAFE, you could do an uplift analysis, and what you can do is at the positions of the anchors, you could provide some point springs. So at position of anchors, you provide point spring, and you assign the spring stiffness based on the expected tensile force that your anchor can resist, and the uh, elongation or deflection value, settlement value, delta. So approximately from this, you could calculate the spring stiffness, and then assign those spring stiffness to these points where you think or where you are deciding to provide anchors, and then do an analysis and see what's happening. So I think this type of a calculation you can do uh, if you want to simulate the rock anchor behavior. I have never done it myself, but I think this type of work can be done in safe. Okay, right. So this was Engineer Rishabh with his query. Now we have a query that has been asked on WhatsApp. What is saying? Engineer Samarth KS is asking the following query. As per IS 3370 Part 2, is it mandatory to check crack widths using annexure A in addition to annexure B? Considering that clause, when movement joints are provided at center to center spacing of not more than 15 meter, the subsequent temperature fall T2 not to be considered. Can we limit our design checks only to annexure B for mature concrete? Yeah, I think in my opinion, annexure B for checking crack widths is sufficient in mature concrete. Generally, in immature concrete, that means the concrete which has not set, over there we generally do not do the crack width calculations. So usually all the crack width calculations is done post the concrete has set, and uh, when that concrete starts to be loaded with liquid retaining or soil retaining, soil or liquid. So I think annexure B for crack width calculation is okay due to temperature or moisture effects. I have never seen in design at least that being checked. And see, if you what you can do is, you will have cracks in the concrete because there will be shrinkage related cracks. So what we desire to have is well distributed fine cracks. Okay, so by controlling the water cement ratio in the concrete, by providing reinforcements which are at close spacings, you could have well distributed fine shrinkage cracks in immature concrete, which will not be a problem for you. So I think checking for immature concrete cracks is not required. You just ensure a few things are provided in your mix design, and some proper reinforcement detailing is done, and I think then you can uh, check only for the cracks in mature concrete. Okay, all right. Mr. Ajinkya is asking, can you please explain how to interpret the F12, M12, S12 in ETABS while checking shell stresses? 1122 is understandable. F12, M12, S12. Yeah, I also have a lot of doubts about F12, M12, S12. So some people say it is sort of the diagonal Let's say in this slab, if this was 1 1, if this is 2 2, so if M11 moment was for reinforcement in this direction, and let's say M22 was for, let's say, reinforcement in this direction, so M12 is sort of some diagonal reinforcement requirements or stresses in this direction, especially that you see in the corners getting generated. So this is what few people say, although I have not deeply thought about it, but the behavior, uh, when we see the M12 movements, the behavior is something like this. The diagonals reinforcement requirement, let's call it that way, and this you see mostly at the corners where the slab edges are there, or even in openings. If you have an opening in slab anywhere, then the M12 stresses you will see getting concentrated. So my understanding, although it's not very clear, it is that these are sort of some diagonal uh, stresses. M12 indicates the stresses in this direction where you may have to provide some diagonal direction reinforcement. Although my understanding is not very clear on this. And I have not got very good explanation in the uh, ETABS documentation also. Yeah. Okay. Then Mr. Animesh Mahato is asking, in canal pipe carrying RCC structure, should I consider water current force and wind force simultaneously? What load combination limit state of collapse should be identical, or reduction of wind load? No, see, if your structure is meant to carry water, if your structure is meant to carry water, then there will always be a situation that water is flowing and plus there is a wind event. Okay, so water is flowing in the canal because the purpose of that structure is to carry water. So water is flowing and there is a wind event also simultaneously. So in such cases, then you have to consider both combination. I mean, you have to consider a combination where both wind and water pressure are taken simultaneously acting. Okay, so making reductions, I think, may not be logical, because you are not going to, let's say, are you going to do this that if there is a cyclonic event, or if there is a if there is a high wind velocity event, are you going to stop the water flow in the canal? Are you going to switch that off, or are you going to turn that off? So mostly it will not be the case. You are not going to turn off the water supply in an event of cyclone or high wind intensity event. So therefore, in such cases, reduction of wind load for combined load combination, according to me, does not make sense. So you should consider the uh, maximum possible load combination for wind and for water as well. This is what I understand from uh, this simple logic. See, in case of industrial sheds where we are, let's say, operating cranes and where we have the possibility of wind loads also, there we do this kind of a work that we take, let's say, the full wind load, and over there we do not take the crane load, because the logic we use is that we will not uh, carry on with the crane operation when there is a cyclonic event, because these days you have sufficient warning systems in place whereby you know that a cyclonic event is coming, so you will stop the crane activities. So over there we use such logic, but the same logic you need to ask uh, the people who are involved in this project, that are you going to turn off the water supply in case of a high wind event or cyclonic event? So I don't think there will be switching of the water supply. So therefore, no reduction in wind load or in water pressure load shall be made in combined combinations. Next question is from Mm, Engineer Kishan, he is joining us from Bengaluru and he's a working professional. Can we use the time period formula of bare frame in seismic analysis of RCC frame structure when the building is using lightweight blocks for masonry walls? No, so if you are using block walls, if you have masonry walls, use that formula 0.09 H over root D. Code is quite clear in giving you that formula. So if you have a bare RCC frame, just the beam and column and slab, then you use the that 0.085 H to the power, whatever that formula is, 0.75. Otherwise, you have to use this. Code tells this to code tells this quite clearly to you. Okay. All right. Then what else do we have? So these were the queries that were there in the on the Google form, and we have taken the live queries from the YouTube comments also. Mr. Rishabh Thakre is asking what precautions should be taken for design of slab with point loads. So design for slab with point loads, you should check for punching effects. Okay, punching can be a problem, so check for punching effects. Check for local moments that you might get, local moment and shears, concentrated moments and shears that you might get. And then for point loads, there are yeah, you also check how you are going to rest that point load on slab. So generally, even though we call it as a point load, there will be some bearing plate through which that point load will be transferred. So check for that also, what is the dimension of that bearing plate, what is the thickness of that bearing plate. So check for all those things. Mostly punching and local deflections and local moments and shears below the point load are critical, and they should be checked. Generally, on slabs, we try and avoid having point loads. As far as possible, we will always try to have beams below the slabs where you have got point loads. Okay. Okay. Anything else? Yes. So, any other query? Okay. So, I think there are no more questions. So there are no more queries, I guess. So then that's it for this week. Thank you very much for joining us. Um, and as I have always told you that the same link you can use for putting your queries throughout the week. And once every week, we take up your queries on this live session that we conduct. So the Google form to provide or to put your queries, I've just put in the live comments. So this Google form remains the same where you can put your queries. And uh, if you want to connect with us on WhatsApp, you can use this link. I'll just put that as well. So this is the link if you want to connect with us on WhatsApp. Yes. Okay, so Mr. Rishabh is asking, in Maiwan construction, lateral load resisting system are cast along with RCC walls for partition. Does it affect the system? So they maintain this care that if they are doing this Maiwan, I mean aluminum formwork for walls, what they will do is they will not have connections made between the, let's say this was your, I'm showing you a plan view. So this is your LLRS, lateral load resisting system, and then these are non-load bearing block walls, lateral load bearing block, non-load bearing block walls. So then this connection that they will make, this is not load bearing. So this connection that they make with the LLRS, or even the connections that they make with the beam bottoms or the floor slabs, those are sort of connections whereby uh, you can assume that lateral loads will not be transferred. So that is the care that they take in the integration or in the connection between these block walls or non-load bearing walls with the LLRS system in Maiwan construction or aluminium formwork construction. Okay. So even though they are cast together, still, as I told you, the detailing they take care in that way that the load transfer is not significant between the two systems. One is your non-load bearing walls, and one is the uh, one are the walls which are part of lateral load resisting systems. Okay. Anything else? Okay then. So I think that's all for this week. We will meet you again next weekend. So you can use this Google form for putting your queries. And if you want to get in touch with us, this is the way to connect with us on WhatsApp. So that's all. Thank you and see you next time now. Bye bye. Thank you so much for joining.